Case study: Revolutionizing Cybersecurity, AI-enhanced intrusion detection systems in practice at Cybertech. Intrusion detection systems have become indispensable in modern cybersecurity, transforming from rudimentary rule-based mechanisms to advanced, intelligent systems empowered by artificial intelligence. In a tech company known as Cybertech, the security team faced a formidable challenge. An increasing number of sophisticated cyber threats were slipping past their conventional IDS, endangering sensitive client data and proprietary information. Cybertech's Chief Information Security Officer, Rachel, convened a meeting to explore the integration of AI into their IDS framework. The team included Sam, a seasoned network engineer, Lisa, a data scientist with expertise in machine learning, and Mike, a cybersecurity analyst familiar with deep learning algorithms. Rachel emphasized the urgency of upgrading their IDS, noting that traditional systems were no longer sufficient to combat the advanced tactics employed by cybercriminals. Sam started by outlining the deficiencies of their current system, which relied heavily on predefined rules to detect anomalies. He explained that while this approach worked for known threats, it failed to adapt to new, unknown attack patterns. Lisa proposed leveraging ML to enhance their IDS capabilities, starting with the implementation of support vector machines. She explained that SVMs excelled in binary classification tasks, such as distinguishing normal network traffic from potentially malicious activity. This prompted Rachel to ask, how can we ensure the SVM model remains effective with the evolving nature of cyber threats? Lisa responded that the effectiveness of SVMs hinges on continuous learning and adaptation. She emphasized the importance of regularly updating the training data to reflect the latest threat landscape. This involves pre-processing large volumes of network traffic data to extract relevant features and selecting the most informative ones for training the SVM model. Mike added that SVMs could be calibrated to minimize false positives, which are a significant drawback in traditional IDS. However, he raised a concern about the scalability of SVMs, particularly when dealing with high-dimensional data from extensive network logs. To address scalability, Lisa suggested exploring random forest algorithms. Unlike SVMs, random forests can manage large datasets with numerous features, making them suitable for IDS applications. She explained that random forests operate by constructing multiple decision trees and aggregating their outputs to improve prediction accuracy and robustness. Rachel queried, what specific types of intrusions can random forests detect more effectively than SVMs? Sam pointed out that random forests are particularly adept at identifying complex patterns, such as those found in port scanning and brute force attacks. Their ability to handle noisy data and avoid overfitting makes them a valuable asset in intrusion detection. However, he cautioned that the interpretability of random forests could be challenging, as the ensemble nature of the model makes it harder to pinpoint which features are driving the decisions. The discussion then shifted to deep learning, with Mike highlighting its potential to revolutionize IDS. He introduced the concept of convolutional neural networks, which, although traditionally used for image processing, could be repurposed to analyze network traffic by treating it as spatial data. Rachel asked, how can CNNs provide an edge in detecting network intrusions? Mike explained that CNNs can capture spatial dependencies in network traffic data, enabling them to identify subtle patterns indicative of specific intrusions. For instance, CNNs can detect distributed denial of service attacks by recognizing abnormal traffic spikes. He also mentioned recurrent neural networks, particularly long short-term memory networks, as powerful tools for analyzing sequential data like network traffic logs. LSTMs can learn temporal dependencies, making them ideal for detecting anomalies over time, such as slow and stealthy attacks. Lisa raised a critical point about the quality of training data, noting that both ML and DL models rely on vast amounts of labeled data. She shared that obtaining high-quality labeled data is often a hurdle due to privacy concerns and the dynamic nature of cyber threats. Rachel then inquired, how can we overcome the limitations posed by the availability and quality of training data? Lisa proposed using unsupervised learning techniques to mitigate this issue. Unsupervised learning can identify anomalies without labeled data by learning the normal behavior of the network and flagging any deviations. Techniques like clustering and autoencoders can be particularly useful in this regard. Additionally, she suggested employing semi-supervised learning, which combines a small amount of labeled data with a large pool of unlabeled data to improve model performance. Mike brought up another challenge: adversarial attacks. He explained that attackers could craft inputs designed to deceive AI models, causing them to misclassify malicious activities as benign. Rachel questioned, what measures can we take to protect our AI-based IDS from adversarial attacks? Mike recommended incorporating adversarial training, a technique where the model is trained on both genuine and adversarial examples to build resilience against such attacks. He also advocated for the development of explainable AI to enhance transparency and trust in AI-based IDS. XAI techniques can provide insights into the decision-making process of AI models, making it easier for security professionals to understand and respond to detected threats. As the meeting progressed, the team considered the broader implications of integrating AI into their IDS. Rachel wondered, how can small and medium-sized enterprises benefit from AI-enhanced IDS given their limited resources? Sam suggested that cloud-based IDS solutions powered by AI could offer a scalable and cost-effective option for SMEs. These solutions provide real-time threat detection and response capabilities without the need for substantial on-premise infrastructure investments. Lisa added that such cloud-based systems could leverage collective intelligence by pooling threat data from multiple sources, enhancing the overall detection accuracy and speed. In conclusion, the integration of AI into IDS can transform cybersecurity, making it more adaptive and proactive. However, to fully harness AI's potential, organizations must address challenges related to data quality, scalability, interpretability, and adversarial robustness. Continuous learning, adversarial training, and leveraging cloud-based solutions can help overcome these barriers. As Cybertech embarks on their journey to implement AI-enhanced IDS, they set an example of how advanced technologies can fortify defenses against an ever-evolving threat landscape.